Hello, sir.
Hello. Hey, everyone. Can you guys hear me?
Yeah, please let us know if we can hear Shumo well. I can hear you very well in front of
Okay,
your
great.
Greek
Also,
wall.
perfect. And also, Gaylord, please remind me the time if I'm running over time in the end. Just
Yeah, we'll do. We'll do. I will
okay.
just pop up on stage in case you need to rush or slow down, or maybe there are questions that we missed. But
Okay,
I'll
great.
make myself known. But for now, I will stay in the background. I will just pop up your screen on stage instead of mine. Here you go. Excellent.
Awesome.
So yeah, feel free to take some breaks to check if there are questions in the chat. We want that to be interactive as well. But
Mhm.
now I will leave it up to you. So yeah, good luck with the workshop. Looking forward to it actually. And yeah, I'll be in the background if there's anything. Just talk to me. I will hear you.
Okay, great. Amazing. Hey, everyone. My name is Shumo. I'm the CEO and co-founder of Nebra. And first, thanks a lot for both Anna and Gaylord for organizing this amazing event. I see great vibes here. Let's get into it. First, this is our community link. So it's a very high quality community. There's a lot of very serious technical discussions and ZK development. Please join us and scan the QR code so that we can still interact after this ZK hack. I'll stay here for a while to give you guys some time here. Okay, great. So first, let me give you an introduction of our live product. So the first product we live called Nebra UPA. From the high-level point of view, Nebra UPA is a very simple product. It gives you 10x reduce on the verification gas cost. For example, for Nebra, before using us, you probably need a 250K gas to verify a single ZK proof. Now, using us, it's roughly like 25K to 30K. And secondly, this product is purely secured by cryptographic security, which means we're using recursive snarks. The way we're reducing the gas cost is to val proof aggregation. So eventually, the security of the proof is verified on the base layer. So there's no other kind of securities. There's no shenanigans here. Last but not least, so we're actually live on Ethereum, Base, and World. So the Base will be live actually later today or tomorrow, but the address is already there. So instead of giving you a PowerPoint or slides presentation, so let me just give you a deep dive to our product doc. So let me stop sharing here. See the screen now? Yeah, also, please comment anything in the stream. Okay, great. So I think, like I said, the goal of the project is to reduce the on-chain verification cost. So, and this is high level how it works. Let me make the screen bigger. So the high level thing here is that, so you can think of Nebra as a Uber pool. So the purpose here is that we can aggregate proofs from different circuit, different parties into the same aggregated proof and getting verified on chain. So instead of paying the proof cost for each single individual proof, now you just pay the same cost for 32 proofs. So this is a workflow for any kind of ZK-powered application using Nebra. First is that you register your verification key using Nebra UPA, and this gives you a circuit ID. And we have a TypeScript SDK to handle everything for you. It's just a few keystroke in the command line, so it's really easy to use. And secondly, you submit your proof to Nebra UPA together with a public input associated with the proof. And then there is a Nebra UPA contract entry point. You're just waiting for the event that indicating that the proof is verified. Now, after this event, you can continue your business logic by querying the isVerified function in our like a smart contract to execute the application logic. And last but not least, so the verified rejected proofs can be viewed at Nebra Proof Explorer. So I will show that later. So that's a very high level. So then let's actually just go through how like you can use in Nebra. So the first is setup. So again, we publish this like a Nebra UPA as a TypeScript package. So all you need to do is a yarn add Nebra UPA, so for we are fully tested using ethers, so you should install ethers for the convenience. And then basically you can so we developed this like a UPA client. So it's basically a command line tools for you to interact. For example, in so this is Node.js code. In this Node.js code, you can see normally you would import like ethers or like some other stuff. So the difference here is that you just import UPA client from the UPA SDK, and also import config from the UPA tool. And now you can, this is pretty much everything. So let's go to the register applications. So in the register applications, so the way you can think about Nebra is that instead of normally if you want to coding like a ZK applications, you need to sort of writing your own, however you call it, like a verifier.so. That could be a gross-16 verifier, that could be a Plonk verifier. By using Nebra, you don't have to using that. So instead, you need to register your verification key with us first. So basically, the Nebra UPA contract expose a register VK method, which accepts the verification key you can use. And then we will, for the convenience, so basically this tool will give you a circuit ID. So this is a unique identifier for your circuit, so that after register the verification key, you can use it. So it's rather straightforward. So again, the best way is still basically using depending. So basically, the current Nebra UPA support 2 concrete proof systems. So the proof system implementations. So the first is Snark.js, and second is Gnark, right? So we have the coding examples for both. How do you register your verification key, either in Snark.js or in like Gnark. So there is a difference between the serialization format of the Snark.js and the Gnark, but don't worry, we handle that for you. So everything is just like usable using our TypeScript SDK. So that's a high level of the register applications. So you can see all you need is basically having the UPA tools, and you can do that by either in your like a TypeScript code or using a command line tool. So then the next step is, hey, like now you have registered verification key. Now you basically are free to use Nebra UPA. So this is like how you submit and verify your proof. So again, right? So basically, we're like assuming you are using some like a JavaScript or TypeScript SDK, TypeScript like environment. So again, for both Snark.js and Gnark, so you can we basically implementing this like helper functions for you to submit the proofs to Nebra UPA. Yeah, please dive deep into. Please check the documentation for the further details, and also join our Telegram group for like technical support. So now after you submit the proofs, the thing you can look at is our Proof Explorer. So let me give you a brief tour of the Proof Explorer here. So this is our Proof Explorer. So you can see the link here is like a nebrascan.io. So go to nebrascan.io. So you can choose the different deployment. So this is Ethereum, Sepolia, like a World Chain Sepolia, and World Chain. So you can see these are the running proofs. For example, let me show the historical proof. So we have, so you can, in each single proof submission, you could have submit a single proof or submit a batch of proofs. So this is a single proof batch which contains one single submission. But inside of this single proof submission, there are 4 proofs. And now you can see the concept, right? So this for each single proof within this submission, and there is a circuit ID and there is a proof ID. So this proof ID is a like unique identifier for this single proof, and this circuit ID is the basically the check hash of the verification key I just mentioned. So and if you look at this circuit ID, you can see like all the previous proof being submitted as well. So in Nebra UPA, we are actually planning to, for example, actually replace the circuit ID with some meaningful things. For example, for the circuit, this is a Sommerfeld circuit, and this is, I don't know, like your ZK EVM circuit, to have like a human readable like metadata replace the circuit ID. But this is still kind of like a work in progress. Yeah. So let's go back to the docs. So, and then we have 2 very detailed, comprehensive sections of the gas cost. So, so we have 2 kind of gas costs right now. One is because we have 2 submission interface. One is like off-chain submission. One is on-chain submission. So you can dive into the details on how the cost differs. The basic thing here is that the off-chain submission will have like much lower gas cost. So for, especially when you're using L2s, right? We basically will recommend you using the off-chain submission interface. So we have a bunch of other features. For example, testing workflow. So basically, we have some like a convenient helper functions for you to test your app without actually even running on testnet. And then we have some additional features in the SDK to help you to do the front-end integration as well. So you can check the current deployment contract here. So we have like a UPA 1.2 deploy on like Ethereum mainnet. We have UPA 2.0 deploy on Sepolia, like World Chain Sepolia and World Chain mainnet. So I guess last but not least, we have off-chain verification tools for you to test because we have received many requests from people like before they actually getting the on-chain verification working, they just want to have an RPC interface to kind of test their ZK applications, to just like having a very easy to use REST API to test their ZK verifications. Basically, we implement that and having this like a one-stop shop for you to do the ZK verification. Yeah, I think that's I just go through the UPA product. I want to pause here a little bit to see, do you guys have any questions? What kind of apps currently using Nebra? So there are a few apps. For example, one is like a Galaxy ID, which is from the project Galaxy, and one is like a the Polyhedra, and the Polyhedra's like a ZK bridge using Nebra, and there are more like applications working on the testnet. And since you are asking about applications, right? So this is actually perfect for me to go to the next sector of this workshop, talking about even more about applications. Just want to share like some cool things happens on Nebra ecosystem. So this is a pretty old like ZK landscape. I know many projects haven't used there. I just want to do a little bit of survey here, right? So we have tons of ZK project. What is the, I mean, of course there is a ZK L2s, except for ZK EVM. What is your daily used ZK application? Or like, I guess like not even daily use. Have you ever used any ZK application on chain? Can you guys type in the comment section? Dark Forest, yeah, that's a very cool like ZK game. Anything else? Tornado, yeah, I use Tornado too. That's great actually. And I use Railgun. Yeah, you see, that's a problem. I claim this is a problem for our entire space, right? So people invest like hundreds of millions of dollars and in this entire space, and no one is using ZK applications today. And WorldCoin is great. Yeah, WorldCoin is a great example. Yeah, indeed. So I think we have a very, it's a very obscure space in the sense that we get hundreds of millions of investment and no one is building applications. That's why us, Nebra, is hyper application focused. We're not building yet another infra, quote unquote infra, to aim for the next token launch, right? So basically, our goal is to help the application developers in the ZK space can work better. So with that, I'm happy to share. It's still kind of in the semi-stealth mode, but it should be open to use pretty soon. So this is the first. This is not by Nebra. This is the project we incubated. We work closely to the founders to launch the consumer-facing applications on Base. So it called proof.fan. What is proof.fan? Again, this is a small teaser. So please follow this like X account. It's really just like x.com, proof.fan. So the whole idea here is that this is a meme coin launchpad for anything. What does that mean here? So everyone knows meme coins, and people want to trade in meme coins. Like you have Doge, you have whatever. But what if you can use these meme coins to funding like public good research, funding research papers, funding ZK cryptographic development like Plunky 3. So I saw the Chen Yoda send a tweet yesterday. Shall we launch a meme coin for Plunky 3? Maybe we should, because it's a well-loved libraries. And why we not like? I think us nerds should be able to launch meme coins and also build a community around that. But the key here is that this is not a normal meme coin launchpad. You can launch a token based on the concept of real-world public good. And this real-world public good can be a research paper and can be open source code like Plunky 3. Can be an X profile. For example, if you find like a Tarun's Twitter is very funny, you can launch a meme coin kind of linking to Tarun's Twitter. How it works is that like any kind of like a meme coin launchpad, it allows anyone to launch a fair launched, no pre-sale tokens. It's totally permissionless. Like anyone can launch any token for anything. But there is a feedback loop here. So we're using like the project we're incubating, they're using ZKTLS to giving 10% of the token supply to the authors or the creators of this real world good. For example, bad jokes not allowed for proof.fan. Yeah. For example, if you launch a research paper, you have an amazing research paper so currently they support arXiv and the Science magazine. Or basically, if your fans launch a token, and then you, the author, being able to be the beneficiaries for the token and using zk-TLS plus Nebra UPA to claim the 10% of the meme coin supply. And I think the team are planning some other features, for example, building paper reading groups and building some other things like next. So this is, I think this is great because the way I view meme coin is like attention economy. And so we want to, so the team wants to like linking the attention economy to public good. So now you can trade in your meme coins of your favorite paper. So I don't want to steal the thunder from the team. So there's like a announcement incoming, and I guess like the team has pitched this idea to many people, and many people getting super excited. But this is what happened next. I guess follow proof.fan, the Twitter, and there is a announcement incoming. And I think I tried their product. The product is like a super smooth, I would say. And I think this is a project like also I personally am very excited about. So okay, so that's and also this is just an example of what kind of project we're very excited to working with. So if you, a hacker, have great ideas of how to build a consumer-facing ZK project, please join our Telegram channel, and you can find me, and feel free to DM me on Twitter as well. So like we're happy to help like you how to just like not just on the ZK technical side, also like brainstorming on go-to-market, like how do you find like angel investors, all this, so on and so forth. Please join us. Please join the crew. And so I truly think we can build the ZK application space together. So that's an example of a Nebra ecosystem project. So next, I will just talking about the things incoming, but we have been cooking this for a while, is we call it like a programmable crypto hacker program. So it's not just ZK. So our take here is that we have done tons of research. We have tons of amazing research, and many of the research ZK Hack and the ZK podcast has been covered so far. But I mean, research is done is overstatement, but you see my sentiment here, right? We've done tons of research, and it is time for shipping. So the way we want to build that is that we want to like curating an open source community to hacking together on cool things. Like our team, Nebra, is specifically interested in, so that we can give you. So these are the following focus areas that we are like especially interested. So first is the quantum proof signature schemes. So as many of you know, right? So Google released their newest generation of quantum computer Willow. Despite this current generation of Willow is not a threat yet to the cryptography or to like programmable cryptography, it actually shows the starting point of the long-term threat of quantum computers to cryptography. I think about the world, there's no blockchain, there's no cryptography. I don't think it's a world that you want to live in. So, unfortunately, many smart cryptographers, they have tons of research on how to build a quantum proof like cryptography. So, in fact, I used to co-author a paper of the quantum proof like a VRF functions, which can be a building block for the future quantum proof blockchains. And so I think one of the most urgent development for quantum proof cryptography is quantum proof signature schemes. And so we have a very good candidate in mind. We want to working together with like some cool hackers to building this like a quantum proof signature schemes together. Again, I will show the Nebra like a community, like a Telegram channel in the end. Question in the audience has bounties for or hackathons. So it's not a super formally thing. So I would say first we have cash price for each task. Which means so for each category, so we have a very specific task, and if you finish the so basically this will be completely open source and based on GitHub. So let's say if you have a PR and there may be like more than one people to join, right? So there are many things can happen. The first scenario is that we see, hey, there's a clearly the best implementation. We just merge the PR, then you get a cash prize. And now, or the second scenario is that, hey, we see the 2 competing PRs or 3 competing PRs, they kind of having some merit of both, and we kind of bring everything together to merge the PR together to take one element of one implementation, then people are going to share the cash prize. So these 2 scenarios could happen. And let's say, or it could be, hey, if the implementation is not to our bar of engineering standard, then maybe we kind of like downgrade the cash price. So anything is possible. It's not, you shouldn't think something like a formal, but really should thinking about, hey, you are joining the community, we're actually building this together. And also, you will get like many gigabrains inside the team. So if you like, if we chat, we do some like a web check, we think, hey, like you are legit hackers, we see your previous code, then we'll directly bring you to our internal dev Discord. That's where we ourselves communicate as a remote team. There's no BS at all. You can just like working with like a world-class cryptographers. So we have many like great cryptographers and engineers. They are super experienced in implementing this kind of schemes. So okay. Any links to the programmable? Join our Telegram chat first. So we'll release the programmable cryptography hacker program, the details soon. So this is a teaser, and this is basically show you like why we're building this and what is specific problems. What are the specific problems we're building? Yeah. Okay, great. So the second, I'll just like, yeah, I think it's really like a building together, and so I think so join the Telegram first. So I will have the Telegram. Yeah, let me get a. Okay, great. Thank you so much, ZK Hack. Yeah, join the Telegram. So great, awesome. Yeah, I'll show the QR code last. Okay. The second, I think the second concrete thing we want to work on is fast GKR to GKR recursion. So, like, I guess respond in the comments on have you heard about GKR, and do I need to give a little bit background here why we care about the fast GKR to GKR recursion? Okay, maybe I should give a little bit background here. So GKR is a proof system. So so why? I guess the first question is why GKR. So there are a lot of projects using proof systems such as Stark for high performance programmable cryptography. For example, both Succinct and RISC-0, they are using Stark, and Valida using Stark. Don't get me wrong, Stark is great. The problem here is that if you truly want to building like high performance cryptography stuff, I think GKR seems to be the only solution right now. There are 2 high level vision or insight. The first high level vision here is that GKR is a linear proof system, which means the prover time is linear to the computational load. And the Stark, for example, like a Plunky 3, it's a n-log n prover. So you might say, hey, it's just log n, right? Maybe not super big. But the reality is that we are targeting bigger and bigger work node. And for this bigger work node, if your workload is super big, for example, let's say a ZK VM targets trillions or billions and trillions of like CPU cycles, right? Then this login can be huge. This login can means 100x speed up or 1000x speed up. So we think the linear prover, is the way to go. Yes, are there teams building something like this? Yes, please join our Telegram chat. We'll discuss more. We are working together with the Polyhedra team based on building the open source GKR prover implementation called Expander. We are like actually contribute a lot to the Polyhedra upstreams. So how do you address the scale? That's exactly the problem we're trying to solve here. We have some good ideas. So the GKR to GKR recursion, the high level is that, hey, we want to build a GKR circuit to basically a GKR verifier in GKR. The first step is that basically how to write a GKR circuit. And our team is expert in this, right? So we're actually working on this like super mega GKR circuit. And then the scalability challenges is really about, so it's, if you kind of decompose the GKR circuit is layers of sum checks, right? How can you implement the sum checks efficiently? And also there are some like a non-native arithmetic tricks that you need to use here. I think in general, it's just like high performance circuit engineering plus understanding how does a non-native arithmetic works. So that's kind of like a high level, yeah. Any more questions on the GKR side? Okay, great. So then I will move to the next topic is open source the distributed prover network. So I think there are people building prover network already, like Gavolut. Okay, let me answer the question first. So why is this only? I'm not saying it's only a ray of hope, right? So it's just like it's a high level. You need a linear prover, and secondly, I guess the second good point of a GKR here is that you don't have to commit the intermediate witnesses. So for example, this comes very, very handy, let's say if you're building a ZK VM, or if you're building like a large language models, like layers of neural networks. To think about it, you don't need to do a cryptographic commitment over all the intermediate computation results in, let's say, a 20-layer neural network. So then you find like you have a limited amount of choices on how to build a proof system if you want to have a both linear prover and don't commit the intermediate witness. And you will end up building something pretty similar to GKR. Yeah, I think in the ZK Zero Knowledge podcast and also ZK whiteboard sessions, there are many great Justin Saylor kind of like whiteboard sessions about GKR. Like there are more insight over there. But from the high level point of view, I guess I shouldn't say it's only ray of hope. It's just like the only ray of hope I know, because these two properties of GKR is super critical for the high performance like a proof system, and none of the existing other known proof system actually offers. So, and also you can view like Jolt or like Spartan that Jolt ZKVM uses as a 2-layer of GKR, right? I mean, if you're thinking about GKR in the broader term, I guess the sum check is the way to do it, because like that seems to be the known way of building something like a linear prover and has all these like advantages. Yeah. Okay, great. Yeah, thanks so much for the questions. This makes my like workshop so much fun. Yeah, and also just like So here is my like a Telegram handle. I post my Telegram handle here. Like if you just like want to join the programmable cryptography hacker program, just like DM me. That's the most easy way, and we should chat. Yeah. So okay, next question. So the open source distributed prover network. Like I said, there are many teams already building like prover network. For example, like a Gavelut, for example, Sync, for example, RISC-0. Like why we need a building an open source prover network? And so I think there is a question about security risk. I will address that later. Definitely, like this is like one of the things. I think the first question here is that it's really hard to build a prover network without assumptions of the proof system. And this is related to, I explained like why GKR, right? So if you are GKR peeled, then you will find all the existing prover network, either it's not open source. For example, I'm not sure Sync and RISC-0 are gonna open source their prover network in the future, but it's not right now. Or some existing open source framework has, you kind of having to assume how does the prover works to build an open source prover network. Like if it's too general, you're actually losing the performance here. So I think like we want to be opinionated in a way that because GKR can be fully distributed in a way that if you have a fast GKR to GKR recursion, then this entire thing could be fully distributed. And then you can have like a super high performance prover network. So we want to be like utilizing the high performance aspects of the GKR. So instead of having a very generic code for the prover network, because ultimately people don't care the proof system. Like I think in my view, kind of like a proof system diversity is not a goal we should achieve, because people just using the fastest proof system ever, and to generate the proof and then verify the proof. So basically, we want to have an opinionated way of building this like open source distributing prover network instead of so for example an opinionated approach like Gavelut, or for example some very ZKVM specific like Sync or RISC-0s. So to answer the questions like what security risk arises in open source prover network, so it's I guess like first it should always be open source. If there's a higher risk if something is non-open sourced. Secondly, it's if you're building a permissionless network, so you need to solve the problem of someone may be eavesdropping your proofs. So for example, the prover network, while having some incentive mechanisms to give reward for the workers contributing their hardware resources, their electricity to generating the proof. And now, if that's a permissionless network, let's say you post a proof of this kind of particular workload, if someone else can very easily to fake generate another proof with the same thing and claim your reward, right? You kind of getting screwed. So this is the issues. How do you this is one of the issues of the security issues of designing. This is solvable. There are like multiple ways of solving this. But I think the most important thing here is basically start building this and start to like think bigger. How can we build in like a decentralized network of provers, and to actually targeting very ambitious tasks, for example, on-chain LLM, all this like a very ambitious task. That's I think that's a high level take here, right? And it's better to building something from the bottom up, from the scratch, and to be decentralized from the first place, rather than having kind of like a centralized approach for the prover network. Okay. I think that's the end of that's the end of the workshop. I think I have like a 15 minutes here to hang out here with you guys and to ask any questions, to answer questions.
Hey, we're back.
Great.
Can you hear me? Yeah.
Yes.
So maybe I have maybe one question for you. So what's the immediate next thing? So you mentioned your deployment on base. I mean, can you maybe give us some alpha about maybe further deployment that are coming, that are in the pipe? Before
I see. So basically, we deploy on base, a bunch of projects using us on base. So if you are deploying a ZK application on base or planning to deploy a ZK application on base, please just contact me, right? So then we'll basically help you both technically and to think about go to market, right? So I guess our as a UPA, the product, our entire focus will be on the consumer applications, because we think this is how can we move the ZK space forward. So we have too many, way too many infras, way too less applications. And the benefit of using Nebra is that if you're building a ZK application, we basically lower your user acquisition cost by 10x. So by using Nebra, you have a much better competitive advantages with other ZK applications not using Nebra. So that's a high level take here. Yeah, I guess some questions. Have you thought about creating content about Nebra in Spanish? Would love to. Please DM me. I'm happy to having some community members to help us creating Nebra content in Spanish. And so I think there's many great developers in Spain, and we have a team member in Spain, and he lives in a very interesting beach town called Gijón. Any Spanish people know Gijón? Yeah. So that's great. Yeah.
So it's actually a good transition for me about the ZK job fair. So there are a bunch of jobs that have been posted on the jobs board, but also some companies are just there to to talk to you. I guess that's going to be maybe your case, Shumo. And there are yes, there are quite a few posts that are related to engineering job or cryptographer, but there are also a few community or partnership development or this type of things as well. So if you're curious about ZK but feeling a bit shy, or you feel like you don't have the skills, the technical skills to make it into the industry, well, fret not, there are other ways. As Shumo said, we're kind of beyond the step of infra only, and there are applications with hopefully good distribution for them. So yeah, I think non-technical roles are going to be more and more popular and needed in the ZK space. So yet another reason to join the ZK job fair. That will be after the prize ceremony that we will be starting in a bit, as soon as I see Anna popping up.
Okay, great. Thank you so much, Gaylord. I don't have any more, but I really appreciate you guys having me here. Yeah.
Thank you very much. So yeah, thanks, Shumo. Maybe see you around at the ZK job fair. And yeah, thanks for the workshop.
Great. Yeah.
Cheers.